Welcome to clickmyproject.com. Our product title is Optimal PMU Placement for Numerical Observability Considering Fixed Channel Capacity, a Semi-Definite Programming Approach. Next we see about abstract of our product. The cost of upgrading a substation, which is much larger than the cost of an individual device. It has emerged as the primary constituent of the total expenditure. Under such circumstances, the optimal Besar measurement unit placement formulation needs to consider not only the number of devices that must be placed at the substations, but also the number of substations that must be upgraded to support those devices. In this proposed implementation is to solve the problem of optimal placement of Besar measurement units, considering the exceedance of conventional measurements and zero injection as well as the impact of PMU channel limits. The proposed formulation can prevent the wasteful utilization of different PMUs, observing incident branch current Besars at a given bus more than once. This method is tested on the IEEE 57 bus data system. In particular, we cast the optimal placement problem in a unified formulation as a semi-definite program with integer variables and constraints that guarantee observability in case of measurement losses. Last but not least, we propose a realization scheme of the original integral constraint with randomizing techniques which closely approximated the optimum deployment. This proposed simulation is done in MATLAB environment. Next we see about flow diagram of our product. This is our flow diagram. Generally, the PMU placement is depend on the optimization of power flow. The optimization of power flow is determine the overall power system and power factor of that electrical system. First of all, we compute the parameters of the each power system transmission and distribution side. After that, we formulate the optimization model. Here we using semi-definite programming approach. Using that formulation model, the parameters are solved under the formulation of objective function. After that, apply STP optimization, that means semi-definite programming approach optimization. That optimization is clearly placed the corresponding PMU in which places. After the process will be stopped. Generally, a synchronous Besar is a Besar that is time stamped to an externally precise and accurate time reference. Basically, a solid state relay or digital fault recorder with GPS clocks. Synchronized Besar provide a real-time measurement of electrical quantities across the power system. The resultant time tagged Besars can be transmitted to a local or remote receiver at rates up to 60 samples per second. Continuously measures voltage and current Besars and other key parameters and transmit time stamped messages. Besar data concentrated aligns information by time, the incoming PMU messages from multiple measuring devices, and sends out the aggregated synchronized data set a single data stream. Archive data and process the information, exchange the records with PDCs at other locations. Communication links multiple PMUs to a PDC that links multiple sources, and that capture Besars are to be time tagged based on the time of the UTC time reference. The SOC time counts the number of seconds that have occurred since the consumption. After that block is optimal PMU placement. That optimal PMU placement is depend on the semi-definite programming approach. After that, power will be flow to the load. Next we see about running process of our product. In this proposed implementation is done in MATLAB 2013 environment. First to open the MATLAB window and select the new script and creating that corresponding script name. After that we typing the coding as per the objective function. The objective function is depend on the formulation of semi-definite programming approach. After entering the coding we click the run icon. That new window will be open. That window asks where the data sheet will be placed in our desktop. After that clicking the corresponding data sheet. Here we using IEEE 57 bus data sheet system. So that after clicking that data the output scopes will be displayed in the corresponding window. The first one is a M file. Here we typing the coding as per the objective function. After that this is the total buses in the 57 bus system, and this is the PMU placement in IEEE 57 buses. And after that this is the iterative course waveform. First one iterative best cost maintain and average node branching, and the overall outputs are shown in the corresponding scopes of our MATLAB window. Thank you for watching this video.